Section 250.44 of the National Electrical Code requires that metal objects likely to become energized must be connected to the grounding system. Steel plates on the floor of a commercial facility where portable electrical equipment is used are likely to become energized in the event of a ground fault or insulation damage. Ungrounded metal plates create a potential safety hazard. If a ground fault occurs on equipment resting on the plates, or if an extension cord is damaged, the plates could become energized and pose a shock or electrocution risk to personnel who come into contact with them. Grounding the steel plates helps protect sensitive electrical equipment from damage caused by ground faults. Providing a low resistance path to ground, the plates divert fault currents away from equipment and prevent them from causing electrical damage. The grounding system should be designed in accordance with Article 250 of the NEC. This may involve using grounding electrodes, ground wires, and ground rods. The steel plates should be properly bonded together to ensure electrical continuity. This can be achieved using bonding jumpers or welding. The grounding system and steel plates should be periodically inspected and maintained to ensure proper electrical safety. When dealing with metal objects and electrical safety, ensuring a connection to the grounding system is paramount. Section 250.44 in the National Electrical Code emphasizes this requirement, stating that any metal object with a reasonable chance of becoming energized should be grounded. Consider steel plates laid on a commercial facility floor where various electrical tools and equipment are in constant use. Because of their location and purpose, these plates are prone to becoming energized if there's a ground fault or damaged insulation. Neglecting to ground these steel plates poses a significant safety risk. Without a proper ground connection, if a fault occurs in the equipment placed on the plates or damage occurs to an extension cord, the plates can become energized and present a shock hazard to anyone who comes into contact with them. By grounding the steel plates, you are not only ensuring a safer environment for workers but also protecting sensitive electrical equipment from damage caused by ground faults. When a ground fault occurs, the plates provide a low resistance path to the ground, diverting the fault current away from any equipment that may be susceptible to electrical damage. Implementing a grounding system should align with Article 250 of the National Electrical Code. This typically involves using grounding electrodes, ground wires, and ground rods to create a reliable path to the ground. To ensure electrical continuity, steel plates should be properly bonded together. Bonding jumpers or welding can effectively achieve this. Regular inspection and maintenance of the grounding system and steel plates are essential for maintaining electrical safety. This includes checking the integrity of grounding connections, looking for signs of corrosion or damage, and verifying that the bonding is intact. Grounding serves as a protective measure against electrical hazards. A ground fault occurs when there is an unintended connection between a live conductor and a grounded surface. Grounding provides a low impedance path for the fault current to flow back to the source, causing the overcurrent protective device, such as a circuit breaker or fuse, to trip and energize the circuit. This prevents the grounded surface from becoming energized, which could pose a shock hazard to individuals who come into contact with it. Bonding ensures that all metal parts of an electrical system are electrically connected to form a continuous conductive path. This minimizes voltage differences between different metal parts, reducing the risk of electric shock. Bonding is particularly important in areas where there is a high risk of electrical faults, such as in industrial facilities or locations with wet conditions. Grounding electrodes are conductive rods, plates, or other devices that are buried in the earth and connected to the grounding system. They provide a direct connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault currents to dissipate. The type and size of grounding electrode required depend on the size and type of electrical system, as well as the soil conditions at the site. Grounding conductors are wires or cables that connect the various parts of the grounding system together. They carry fault currents from metal parts of equipment to the grounding electrode, allowing the overcurrent protective device to trip and energize the circuit. Grounding conductors must be sized according to the size of the circuit they are protecting and must be installed in accordance with the National Electrical Code. Ground fault circuit interrupters, also known as GFCIs, are devices that are designed to detect ground faults and quickly de-energize the circuit. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas where there is a high risk of electric shock. They work by monitoring the current flowing through the circuit and comparing it to the current returning. If there is a difference of more than a few milliamps, the GFCI will trip and shut off the power. Surge protective devices, also known as SPD, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events that cause a sudden increase in voltage. SPD work by diverting the excess voltage to ground, preventing it from damaging sensitive electronic equipment. Electrical safety audits are comprehensive assessments of the electrical safety of a facility or workplace. They are conducted by qualified electrical professionals and involve a thorough inspection of the electrical system, as well as a review of electrical safety policies and procedures. Electrical safety audits can help identify potential hazards and ensure that the electrical system is in compliance with applicable codes and regulations. Lockout/tagout procedures are safety procedures that are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned back on. Lockout/tagout procedures are essential for protecting workers from electrical hazards during maintenance or repair. Electrical safety training is essential for all workers who work with or around electricity. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Electrical safety training can help workers to identify and avoid electrical hazards, reducing the risk of accidents and injuries. Personal protective equipment, also known as PPE, is equipment that is worn to protect workers from electrical hazards. PPE can include items such as insulated gloves, safety glasses, and flame-resistant clothing. The type of PPE required depends on the specific electrical hazards present in the workplace. Qualified electrical workers are individuals who have the skills and knowledge necessary to safely work on electrical systems. They have completed formal electrical training and have experience working on electrical equipment. Qualified electrical workers are responsible for ensuring that electrical work is performed in accordance with applicable codes and regulations. Ground resistance testing is a method of measuring the resistance of the grounding system. This test is used to verify that the grounding system is providing a low impedance path for fault currents to flow back to the source. Ground resistance testing should be performed periodically to ensure that the grounding system is functioning properly. Insulation resistance testing is a method of measuring the resistance of the insulation on electrical conductors. This test is used to verify that the insulation is providing adequate protection against electrical shock. Insulation resistance testing should be performed periodically to ensure that the insulation is not damaged or deteriorated. Overcurrent protection is a method of protecting electrical circuits from excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip and de-energize the circuit if the current exceeds a predetermined level. Overcurrent protection is essential for preventing damage to electrical equipment and for protecting against electrical fires. Short circuit protection is a method of protecting electrical circuits from short circuits. A short circuit occurs when there is an unintended connection between two conductors with different potentials. Short circuit protection devices, such as circuit breakers and fuses, are designed to trip and de-energize the circuit very quickly in the event of a short circuit. Arc flash protection is a method of protecting workers from arc flash hazards. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash protection can include the use of arc-rated clothing, face shields, and other personal protective equipment. Electrical codes and standards are sets of rules and guidelines that are designed to ensure the safety of electrical installations. These codes and standards are developed by organizations such as the National Fire Protection Association (NFPA) and the Institute of Electrical and Electronics Engineers (IEE). Compliance with electrical codes and standards is essential for ensuring the safety of electrical systems. Electrical permits are required for many types of electrical work. The electrical permits are issued by local building departments and are used to ensure that electrical work is performed in accordance with applicable codes and regulations. Electrical inspections are conducted by local building departments to verify that electrical work has been performed in accordance with applicable codes and regulations. Electrical inspections are typically required before a building can be occupied. Here are some additional considerations for grounding steel plates. Firstly, determine the appropriate grounding method based on the specific application and the requirements of the National Electrical Code. Secondly, use grounding electrodes such as ground rods or ground plates to establish a connection to the earth. Thirdly, ensure that the grounding electrodes are properly sized and installed in accordance with the NEC. Fourthly, bond the steel plates together using bonding jumpers to create a continuous electrical path. Fifthly, connect the steel plates to the grounding electrode using a grounding conductor. Sixthly, size the grounding conductor in accordance with the NEC. Seventhly, protect the grounding conductor from physical damage. Eighthly, inspect and test the grounding system regularly to ensure that it is functioning properly. Ninthly, document the grounding system and maintain records of inspections and tests. Tenthly, consult with a qualified electrical professional to ensure that the grounding system is properly designed and installed.